Welcome to another video. Now we are told to find the value of x given that 1 raised to x plus 4 raised to x is equals to 16 raised to x. If you're watching us for the first time, kindly remember to like this video, subscribe to this channel, and leave a comment. I'm going to take you through step by step on how to solve the value of x, and if possible, we're going to verify it. Straight away, let us dive into the solution. And for the first part, if you are given any number raised to power x, then of course we know that 1 raised to power any number will at all time give us 0. So for our first step, I'm going to start by rewriting 1 raised to x as 1 plus 4 raised to x should be equals to 16, since x 1 raised to power x is 1, or any other number, maybe 1, 2, and so on. Next step, I'm going to write this to base 4 as 1 plus 4 raised to x should be equals to 4 squared, and then x is outside. Next part, I'm going to rewrite this by taking x outside, 2 outside, so that it changes to 1 plus 4 raised to x should be equals to 4 raised to x, and then I've just taken 2 outside. Then it's very simple that I have 4 raised to x and 4 raised to x. I'm going to let 4 raised to x to be a known number or any denominator or denotation m, so that my equation now changes to 1 plus m should be equals to m squared from this part. So this is a quadratic equation, meaning that for me to solve it, I'm going to use quadratic formula, and rewriting it or rearranging it, I'm going to have m squared minus m minus 1 should be equals to 0. So for this case, it's easy to see that the coefficient of m squared, I'm going to call it a, is 1. Coefficient of m is negative 1. And my constant term is also negative 1. So substituting each in the formula, I'm going to get that m now is equals to negative of b. So that is negative of b plus or minus the square root of b squared minus 4 times a times c. Everything divided by 2 times a. So I've just substituted the coefficients in the quadratic formula, so that I'm going to end up with m now is equals to 1 plus or minus the square root of course, when you square that you get 1. And then 4 times negative 1 is negative 4, and there's a negative here. So it's going to be positive 4 all over 2. Simplifying it further, m now is equals to 1 plus or minus the square root of 5 all over 2 as my value of m. So I'm going to replace m to where I let it here, so that I have 4 raised to x now is equals to m, but my m now is 1 plus or minus the square root of 5 over 2. So guys, at this stage, since the power of x is unknown, I'll simply introduce the logs on both sides of these equations, so that I have the log of 4 raised to x should be equals to the log of 1 plus or minus square root of 5 over 2, like that, so that this x is going to come down as x to the log of 4 should be equals to the log of 1 plus or minus the square root of 5 over 2. I'm going to divide all through by the log of 4. By the log of 4. So that I cancel like that, and I end up with now the value of x now becomes the log of 1 plus or minus the square root of 5 over 2. Now recall again that wherever you have the log of a divided by the log of b, then this can be written as the log of a to base b. I'm going to apply that at this particular point so that the 4 going to come here as the base, like that. As my value of x, which was required. So punching this in a scientific letter, this value is also equals to 0.3471 when it is positive, or when it is negative, it is also equals to negative of 0.3471. That case. So let us verify if indeed the value of x is either the log of base 4, 1 plus root 5 over 2, or when it is negative, it is the log base 4 of 1 minus root 5 over 2. Remember our question was 1 raised to x plus 4 raised to x should be equals to 16 raised to x. So wherever we have x, I'm going to substitute the positive part for this other side and this other side, and then we confirm if indeed the left hand side matches with the right hand side. So if you're still watching us, kindly comment, share this video, and subscribe. So I'm gonna get 1 raised to the log base 4 of 1 plus root 5 over 2 plus 4 raised to the log of base 4 of 1 plus root 5 over 2 should be equals to, on my right hand side, I'm gonna get 16 raised to log base 4 of 1 plus root 5 over 2. So guys, I told you earlier that wherever you have 1 to raise any number, then that equation now changes to 1, since 1 raised to anything is just 1. Plus, if you look at this, I have the base is 4 and the base is 4. And recall that wherever you have a raised to the log of b base a, then this equation now changes to b, since the base and the base are equal. So it means at this other part, I'm going to remain with 1 plus root 5 over 2. Well, on this other end, I have 16, which I can also write as 4 squared, in bracket the log of 4, 1 plus root 5 over 2. Two can come on the upper part, and the base and the base gonna cancel, so that on this right hand side I'm gonna end up with 1 plus root 5 over 2 squared. So left hand side I have 1 plus root 5 over 2. On my right hand side I have 1 plus root 5 over 2 squared. So rewriting on the left hand side, writing it as a single fraction, I'm going to end up with the 3 plus root 5 over 2. And on my right hand side, if you square this and working it properly, I'm going to have 1 plus root 5 over 2 multiplied by 1 plus root 5 over 2. This can be further written as, I'm going to end up with 6 plus 2 to the root of 5 divided by 4, which of course can be simplified as 3 plus root 5 over 2 is also equals to the left hand side, which I got as root 5 over 2. Hence our proof, and we have verified that the actual value of x was indeed that one. So we've come to the end of this tutorial. Kindly don't forget to like, subscribe, share, leave a comment and an alternative approach to this problem. Let's meet in the next video.